15.6. 15.6. So I think I probably could use a part that we've created this week. I can just start from scratch though too. Um, and so if I go to 15.6 here, let me go take a look back out here. Yeah, let's see here. 15.6 problem is this one here. So the parts themselves are just they're 1/2 inch by 6 mild steel flat bar. That's what I have in my description, 1/2 inch by 6. Maybe we've already used this material, but like I said, I'll just start from I'll start from a new part. Like it's um and then it's so they're 4 by 6. 4 by 6 is my part size by 1/2 inch. So I'll just start with a part that's 4 by 6 1/2 inch and name that thing. So and then I can come back and look at this again. But it just starts with the part that and it's mild steel, so it's gonna be kind of the same way I built all of our parts from our previous weldments. So just a new standard part, and I will create a sketch on the XY plane. Yeah. And it's just 4 by 6. That's just a simple little rectangle here, right? Uh, I'll say it's 6 inches long in this direction and 4 the other one. So there's my dimensionally constrained sketch, but not sketched in or not constrained in model space. So I like these vertical and horizontal constraints, right? So I might take this midpoint to this center point horizontally and this way vertically. That thing is ready to be a 1/2 inch extrusion, so I'll finish that. And then here's my extrusion. And maybe I'll balance it over the center line here, but either way, isn't going to matter too much to us here, other than it needs to be only a 1/2 inch thick, 0.5. And then this is mild steel plate as well. So let's change the material properties up here to be mild steel. Steel, you can type in S and say there's steel. Steel. And then since it's that, I can go ahead and give its description that description here. So let's change my description to say it's 1/2 inch by, I think we called it 4, right? 1/2 inch by 4. Whether I put a space here or not is a little MS plate. 1/2 inch by 4 mild steel plate. I'm not too critical on a space in between or not. Probably they're probably slammed together like this. Sometimes I think we don't have spaces on some of our file descriptions or whatever potentially, but this is okay. I'll say okay. And I just need to save this part. That's a 1/2 inch thick. 1/2 inch thick, yeah. And then I'm saving it in my parts folder for 15.5, 15.6, 15.6. We just have a single part. We have two of the same part for 15.6. So there's my part. It needs an assembly. So let's do it. It needs a weldment assembly. So let's open a new weldment. And let's place those parts in. So it always opens you on that weld tab when you're in a weldment. So I have to remember to place these things on the assemble tab. Place them. Place. Find your part. Here's mine, 15.6 part 1 in class. It's a long parts description there for sure, but or part name. But I need 2 of these things. I'm just going to place 2. I like my view to be shaded with smooth, shaded with edges. Well, ground and root 1, of course. Ground and root that one. Apply. Okay. This technically this is calling that my front view, and I'm not going to place that as my front view, but I'm not going to worry too much because I have that control over my drawing views and what I want to do. So it's okay where this is just a coupon exploration anyway. I just need to butt them in how they fit. So I can or constrain them the way they are kind of in this drawing here. So let's take another hard look here. Just that one butts into the other and kind of creates that, not an outside corner joint, but a corner joint. So I'm going to place them this way, just place them the right way that this, they'll kind of naturally fall together the right way, but however you want to place them is going to be okay. So I'm going to constrain, sure, this end here. I'm going to just butt it into this end here. And so I'll just do surfaces and no planes on this one too, but I want them to be the flush finish. Apply that thing. And then these two, flush finish, apply. So then I've got my joint, and on my drawing, I think it's in this orientation on my drawing. So really my left flipped 90 degrees side is going to be my front view like that. Those are the only constraints I need, and I'm ready to do some weld prep. So let's take a look at what's going on this one. It's going to be a groove weld. So I'm going to zoom in on the weld symbol that's applied to the assignment here. It is a J. It's a J groove. So this is kind of the prep is a J, and only on one plate. And I'm going to put it on that vertical member. It's 30 degrees, which kind of follows into the V groove style or the bevel or just a simple chamfer. I view when it has a degree like this as really from the depth of however deep this J prep is going in, from that depth point out to the surface is going to be a 30 degree angle. So to me that means if I it's hard to see this, but I'll see it better on my part. That means from the point here, because this is a 1/2 inch size weld that's going in here, which really matches my plate. It isn't always the case. And so if it was only like, say my weld was only going to be, this is a 1/2 inch plate though, but say my weld was only going to be a 1/4 inch of J prep, then really that's from like a 1/4 inch deep in here, from that point out to here, out to the point here where the J groove kind of meets that surface there. That's going to be like a 30 degree if it was going to be a straight line. But then of course mine has that additional little scoop out, almost like more material has been removed in a J groove and a U groove than a V groove. Like I get that extra radius scoop out. And that could be a reason for it too. It makes me deposit more material in a J and a U groove than it does a V groove potentially. Definitely changes the way the weld bead meets the surface too. And the welder's going to notice that more under the arc and under the hood, just the way the weld kind of fits into that scoop out. It'll feel different than a V groove under the welding technician will definitely feel that a little bit. But then that's what's going on here. And then what we're going to do is we've got a secondary thing going on, and we have so this is just another reference line. So I can add, a weld symbol can have multiple reference lines added to it. They still apply the same way though. They still have an arrow side, other side, arrow side, other side. So this just says I'm going to do the weld according to these parameters. Then I'm going to, this is a non-destructive test that's been applied here. So RT, so the non-destructive tests, they probably show up in that chapter 18 stuff. They're probably a list. They're always acronyms. You could never memorize all the acronyms. If you looked in chapter 18, there was so many welding acronyms. It's going to be that way for GD&T as well. What RT means to me might be something to you different. Radio transmitter, I don't know. But this is a radiographic test though. And so which is an X-ray test. And so on an X-ray test, what you additionally have to tell beyond just that, I think if they're being very thorough, they will then specify what the testing equipment angle of test needs to be. So in this case, that's what that 30 degree is. It's like, yes, it's a radiographic test. Place the equipment at 30 degrees off of that plane to shoot this test, which means, and then this is a symbol. It's just an asterisk essentially, but it's a symbol for radiographic test equipment. And so that's kind of the equipment's going to be on this 30 degree off that plane. And I'm going to, this is where my equipment's going to be. And then below here, like an X-ray, if you think of your dental, X-ray, they place the radiographic equipment on the outside of your face. Then on the other side, they put a film. So you have this you're shooting through the weldment in this case, or through your teeth. And then the film is stopping the X-rays from there, right? It's like the, yeah. So they would do that here on an X-ray test here. They'd place a film behind this. So they kind of need to know if my equipment's at this 30 degree angle, where's my film going to be placed? So it just helps everyone perform this test the way they have designed it to be taken and the way they're evaluating this weld for whatever reason. I would say it's very specified here. Simplified would be to drop, like if you have experienced radiographic testing technicians, they might not need to know 30 degrees and that, and they know, I can see in some situations maybe you wouldn't call that out if you didn't know, because if that didn't make sense to the technician, he's like, actually, I can't shoot that at 30 degrees. It needs to be 60 degrees. You'd be like, okay, I didn't know that. I'm not a radiographic technician. So you fall into that needing a subject matter expert in some ways here to call that out so specifically. So let's do the prep on that. It's a J, and I don't really have any specifications on the size of that, kind of like the same one I just did. So I'm just going to use this 30 degrees as kind of a target, and this 1/2 inch size, which really is through the entire thickness of the plate here, right? And so here's my assembly. I'm just going to go into the prep mode. So I'm on the weld tab. I'm going to do some prep on this thing. J grooves, U grooves, V grooves, single bevels, they all have a prep stage for sure. Prefab, pre-prep, parts prep. So let's do a sketch here. I'm gonna do it on this plate here. This is the one I'm gonna modify. So there's my sketch plane. And then I'll just project some geometry here. So what I need is this outer surface, right? This one. And maybe the thickness through here. And then it's just an arc that's going to scoop this out. So I can do like a reference. I'm going to do a construction line here. Here's my construction line. And I'm just going to do a line. I'm going to lock in on that point of that endpoint there. And then I'm just going to lock in here. And then I'm going to set this at 30 degrees is what this is. This is just reference material, 30 degrees is what the angle of prep is. If it was just a standard V, single bevel, that's what it would look like. But mine's got that U quality to it. So I'll use a arc, 3-point arc, sure. And this is totally random. I don't really have you an arc radius, but I'm going to use the same thing where select the start of arc, yes, is here. And then select the end of arc, yes, is here. And then what is the angle? I don't know. I just did something. This would have to be called out potentially because this does matter, right? Like how much I scoop out of this parent metal makes a difference. Oh, I don't know. Did I just do like a 0.5? Sure, 0.5. Of course, mine drew as construction because I had it toggled on, so I could just simply select it, turn that off again, and turn it to. Whatever you use there as a radius doesn't matter to me. I'm just kind of maybe matching the thickness. Seems like that's a pretty good little J groove prep. If you did less than that or whatever, it's okay. It doesn't matter. As long as it's more than the bevel that I'm kind of referencing. Or the more than that V if it was just a single normal chamfer. So you can see clearly what it does is it causes the welding technicians to fill in more. There's more material cut out of this. We'd be at now that you're in GED and T, right? We'd be at our least material condition, maybe. The maximum material condition would be out to that. No, not necessarily, but that is the idea, right? I've scooped out more, so I have less metal in there. Least, less weight, least. Most maximum material condition, most weight, most material. Okay, so I'm definitely scooping out more, causing the welder to have to fill in more. Maybe there's more pass sequences. You have to take more runs of this thing, more beads to fill it in. So, but I am at that 30-degree angle. So this is done. I just need to finish the sketch and then do an extrude cut through all like this. I'm gonna say, okay, now I'm ready to weld. Pretty substantial cut. Yeah. I mean, you could perform this weld, then have the welding technician come back and do a fillet weld with some prep, and we could actually, eliminate all the parent metal between those two plates and fill it in totally with filler material if the joint required it. So let's weld this up. This is the kind of welding I wish I would have done in my career mostly. Virtual welding. Hobbyist welding is fun. Welding as a job is work. And is also fun, but it is hard work. Okay, so this would be considered a groove weld. So it's a J groove. That makes sense. It's not a fillet, it's a groove weld. So now I'm on the weld tab. I've selected weld now, and I'm going to say groove. And this is the one we used on that last one too. So I need to select two faces, which this is one face. That whole surface is kind of one face. But we're gonna terminate it by selecting face set two is this little J groove. And then their full face. And then say, okay. It didn't like me, so I don't know why. I'm gonna have to troubleshoot this. I don't exactly know why this didn't like my maybe I don't know. Let's see, radial fill. Oh yeah, because it recognizes that face as a radius to it. Hey, excellent, good, good, good. Radial fill. Say okay. That's the secret sauce. Some of it's just learning the program and how to manipulate to what you want, right? There's a lot of ways you can get the program to do and display something. And the best part's when you work with a bunch of different drafters and you see things that they do that you definitely want to avoid and things that they do that you want to implement yourself. So I'm going to change that weld. So this is done. My welding is done as far as this weld is called out. So I'm going to return back to my only if you select radial fill. Ignore internal loops like this, maybe. When in doubt, just start clicking boxes. When you run out of boxes to click, you may have a joint. You may have just like there might be some way the geometry is working. It doesn't allow it. So it can be some trouble for sure. Yeah, mine didn't need that, but that could be Does that help? Was that helpful at all? Oh, the full fit. Yeah, it seems like on all of our grooves we've had to select. I just changed my weld nugget, my weld bead to steel welded rather than aluminum welded. And now this thing's ready for a drawing. So I got to open up a drawing. I got to save it. Good call. In my assemblies. That is true. 5-6 assembly one in class. Love it. What is it? Minute video? Oh, I think I'm over it, aren't I? Nah, maybe not by much though. I'm close, but I still got to do the drawing and the welding symbol. So I'm never going to make 20 minutes. Give me 20. I knew it was kind of an easier, but the welding symbol is a little bit goofy, and I got to use some little CADD skills. I would say I got to use my AutoCAD hack skills a little bit to make this work for me. So here's my drawing. Wait, I'm going to use my. Sorry, I'm not going to use that one. Didn't really mean to create a new. I got to open up my template. Oh, I was already there. There's my template, my drawing. Place that thing on there. Base view. Which one? This one. Which orientation? Not like that. I'm gonna do some hack method of getting this to my right front view. Close. Got to do one more rotation. That looks correct. View label, yes. 1:1, maybe a little large. Maybe I'm gonna just guess this is 3/4 scale. Without looking at my other one. Oh, I should have done a projected view, which I can always just drop in here and do projected. Oh, and I should do a sorry, I'll do a isometric view too. Yes. I did 1/2. Still, I'm going to make this one quite a bit smaller for sure. Maybe I can keep these at 1/2, but or 3/4 is what I did. 3/4, maybe 1/2. I agree with you. I might do half scale here. Okay, I'll go back. You've convinced me. This thing's way too big. So let me take this one down to maybe a half. Yep, that's that. Of course, the other thing I'd have to be fitting on here is my parts list, right? So, I bring that in sooner than later, just so I can get it on my sheet. Here's my parts list on the annotate tab. Which assembly? It's the only one I have open. No, I actually have two open, so I'm going to pick the right one. 15.6 in class. Love it. Okay. Here it is. 1/2 inch by 4 mild steel plate. That was what we wanted, right? 1/2 inch by 6. I just need to name that 6. I actually named mine wrong. That's okay. That happens. I can jump back into my part real quick. I need to do a file to say that. I'm saving my drawing really quick before I do too much as a different name. my drawings are still in here. 5-6 in class. Okay, I'll move this over here and move this over here. So what do I got? There's my part. Here's my assembly. Here's my part. I've got the wrong description because if you named yours like mine, if you were following along better than I was, then that's better. This is just supposed to be half inch by 6. It matters because it's just a different width material. Technically, I could buy a 1/2 inch by 4 and cut it 6 inches long, and you would think I have the same piece, but I really have it. I could potentially have different grain structure in the material. That's deep level. Don't worry about that yet. But like selecting the right width of flat bar sometimes matters quite a bit. And understanding the way the grain, like I think I did talk about this a little bit, right? Because I said wood has a grain, and when people know what they're doing with wood, they factor in the grain and how it works and works together in a wood construction assembly. Same thing with metal. I sometimes have to consider what is the grain structure of the metal, and am I doing something that could cause, some laminar tearing, just because grain structure will tear differently. And so I may have to worry about how those grain structures are intersecting in welded joints sometimes. Yeah. But that's definitely next level. And so, but what, long story short is, yeah, a 4 inch, yeah, it would matter. So I'm going to say that this should be 1/2 by 6 accordingly to my original plan here. 1/2 by 6 now shows up. And I haven't even got to the weld symbol yet. I saved the best for last here. Let's see. Little refinement. Like I say, I like to get a feel for what my layout of my sheet's going to be. Now let's put some weld symbols in. Really, I'm kind of running out of room there. My weld symbols really, this could be one where if I just didn't have the room, I could call it out here and call it out as other side, right? Could point here, say it other side. Of course, it's easier here in this one, and maybe this is one that's harder to do that with because of the constraints on the radiographic tests. Maybe I can't necessarily do that very easily if I want to specify a test angle like this one does. So maybe this one does restrict me on which side I want to point to. So it's the welding symbol. I'm just going to point to this weld, place this weld. It's going to usually use your last one, and that's not always helpful. So you can say no preset and then start from scratch here. So this is an arrow side weld. Sometimes I like to move this to where I can see what's going to show up on my symbol here as I build it. Arrow side weld, it's like a J groove. So I'm going to kind of look through that here. What do they call it in here? Anything? There's the U. Here's I think they say J groove. Yeah. So it's a J groove arrow side. Love that. It has a couple, like I have a root opening or a gap, but really I don't have that specified. So I just have an angle of 30-degree angle. And then I don't have like a reference size or what I call the real size or the actual size. I kind of have more of a theoretical size given here, which is definitely, like I said, maybe the most common to see is this theoretical size. So that's 1/2 inch, matches our material thickness. Doesn't have to be that way, but it is in this weld. So there's a 1/2 inch, 30-degree J weld. I think that's okay. I just need to add the other symbol. So this down below lower left so that you can add more. So I think add a welding symbol to this will create that branch structure that we see. 1/2 inch 30 jig. That was all for that information. So this next one is not a weld, it's just a test. So that's an option you have. Now I'm into this, this reference lines data now here. So I'm going to select this little stampy thing is non-destructive examinations, according to ANSI. So I select that. It doesn't really auto-populate anything because I don't think they have any presets for those. Unfortunately, I wish they did. I can't believe they don't have these loaded yet to have a drop-down menu for maybe the more common, readily available radio or tests that would have their acronyms associated with it. I got to call Inventor and be like, come on, now you've got this killer welding symbol feature. Why doesn't it have everything I need? My heart's desire. So in this case, I have to know, maybe I don't know if it matters which box I place in it. It probably does according to this test. But if I put RT in here, if I just type in RT, this is the problem I have with it. You'd have to know that that's the acronym for it, right? And then RT gets applied. What if I put RT over here? What does it do? I don't know. Oh, interesting. So one of them is going to be kind of like split on the reference line, halfway, and the other one's going to be, yeah, it's almost like you could necessarily, and I guess that would be if you put your RT across reference line that you're saying you're going to shoot it from both sides, probably. You're gonna radiograph test both sides. So I definitely don't want to do that. I'm just doing arrow side only test. And that's really all to this other, yeah, that's it. So I'm just going to say okay on this. I know there's a few other parameters, but there's no way to put them in here. So that's at least common. Now we're going to get a little more specific, and this is where I get a little catty here, is I'm going to do a sketch on this. I'm just going to do a sketch on this view. So a new sketch. Because what I need is a dimension of 30 degrees. And it doesn't recognize, I don't think this in your dimension tab, if you pull the dimension, and I don't think it recognizes that symbol as a dimensionable thing. Now, my mind always goes, well, how do I turn my welding symbol to be dimensional? And I'm thinking there may be a way. I'd have to dig through something maybe to see if that's a possibility. But I'm just going to draw a line that is in line with my welding symbol here. So I'm going to do a sketch, which here's a start sketch on my annotate tab, or there is a whole sketch tab here, right, too. But maybe I feel like on my drawings, I'm on the annotate tab primarily, and it has most of what I need. So it has this quick sketch right here, start sketch. Or you could probably like right click and say start sketch somewhere maybe, but this one here for sure, start sketch. I'm going to pick this view. And I only do that because I think when I move this view, this sketch will be like, constrained to some of this view. And so what I'm going to do here, I think will move with me. I'll flex that at the end and see if it does. But so now I'm in a sketch mode, kind of in this view, and I'm just going to drop a line that maybe I'm going to target this right here as a constraint. I think I snap that to my midpoint here. I think when I drop my weld symbol, it was to a midpoint. So I can snap to that midpoint. I mean, that's one thing. You may not have done that, and so you may have to. I would look to like start your line wherever your arrowhead is. Like I just don't know if the arrowhead is a constrainable thing. I think I'm picking up a midpoint of that little line like that, and then I'm just going to drag this thing out here. No particular, like I'm just kind of like lining up along my, and this is an unconstrained line. Like I'm not really. This is when I get a little bit. I'm using some trickery here to get this dimension to populate. And so I'm not really constraining this line, actually. Well, I kind of will. I'll use a dimension there because this is dimensionable here from here to here within this sketch. It's kind of like using that as projected geometry in my sketch. And I can set this at 30 degrees, which is the angle of shoot. And then if I finish this sketch, this line still shows up, right? If I finish this sketch, here's just a sketch on my drawing. They live like you can find them here. I don't know. Let's find where my sketch lives here. Right there. There it is. It's in this view. So if you have your B size sheet expanded, bing, and then it has, I don't know how it auto expands, but this is title block changing stuff, which I don't generally change my title block there. But there's where my sketch just showed up. And here's which view that sketch kind of lives with. So, when you're breaking these down, sometimes you're looking at the different views that are available, kind of like you would with features in a part. You can highlight over these and see, oh, that's that view. There's that view over there. And there's quite a bit of manipulation you can do within a view, actually. Like it shows the parts that are in that view. It shows, and I'm just driving down into, you can get to everything of this view. And you can do things specifically to this view only. You can actually hide. It's another thing I don't like to do because it's needles in a haystack, but you can technically hide lines in these views as well. You can turn off their visibility. Like anyway, I don't do that too much unless I have a really good reason if I'm trying to expose some internal on a detail view maybe. But this thing is at 30 degrees, so I think what I did is I just kind of moved this thing to be like eyeball in alignment with my 30-degree line because this is now dimensionable. So I'm not in the sketch at all, right? I'm just back on my sheet like I would normally dimension. And this will now recognize that line as something that I can dimension to. So I have my 30-degree. And then I just add that asterisk, which is another, caddy way. It's just a text box. Like you would any note you need to add here. Here's your text box. And it just shows up like this. And I'd say, oh, what I'm adding is a shift 8. It's an asterisk. I think it's also on your numpad it's the multiplication button. And then the only thing I did, I dropped it in there and I just made it big. I think I made it like the 0.24 of the auto. This is the size that I have on my list. As long as you highlight it, because you can have multiple text sizes in the same text box. You just highlight them and change them. I say okay, and there it is. It lives out here, but it has a grip. I'll escape. And I'll say, heck yes. Heck yes, I will. And that is my equipment. So what I did is I just dropped a text box here. Text box, dropped it. Either use the numpad for the asterisk or shift 8. And then highlighted that to make it big. Said okay. And then I just simply drug this around where I need it. So I don't need that one, but and then what I meant by flex it is like, okay, so I've done some like sketch wizardry here just to make it be what I want it to be. If I move this view, does it come along with me? Everything kind of does except for, so even my little, like my line that was drawn in that sketch, if you wouldn't have picked that view to draw your sketch, you would just be sketching on the paper and you'd have to move that line again, right? So it would be kind of weird. I definitely chose to sketch in that view, kind of makes them tied together. So that as I move that view, I only have minimal data that's not. And this can be pretty common with a lot of text box stuff is that, oh, I always have to sometimes come in here and like manually move if I've done something like this, because I just don't think in the welding symbol setup, they don't have that. In fact, I need to go up. Maybe I'll use my space over here with weld symbol. And now I know how big it is. I can kind of plan for that and move my little shape here. And this one is it done? This one's done. I'm just going to save it. When you save from here, it saves assembly. When you save from drawing, you get these prompt boxes. That's saving the assembly. That's saving the parts. So it's that downstream save. Because when I jump over to this part now, I can just close it because it already knows it's been saved. Last, and then you just need a few more dimensions. I think I still will turn this to be the parent view to be just hidden line or just solid lines, visible lines. And then I get rid of some of those welding prep that I've done there. And I just need to name that welding coupon too. That's probably one thing. Just name this. Go into this. Let's see some other ways. You guys get to your iProperties different ways here. From the parts list, maybe? Yeah. So if you have it up here, although that is the individual part, so you can definitely get into its iProperties. Let me see what I can do with my parts list. There's a lot of driving you can do here. If I go into here, sorry, let's see. What can I do? I don't know. Yeah, definitely. And right click here to get into your, oh yeah. So if you're, oh good. Let me collapse this. Let me build this out. That part. There's my simply so maybe there's no. But here's me in my assembly iProperties. And apply one of those. I don't have a weight here, but I should have updated that while I was in that assembly, right? So this is just me exploring my browser, looking for. There's the assembly again. iProperties. Physical update. Okay, please. If you don't have that assembly open, you may have to open it to like let me close my assembly real quick. Yeah, I'll save it as it is. If you don't have your assembly open and you change that stuff, you may have to open it for it to know how to update its properties. So I just watch for that. And if that's the case, usually when I'm in my drawing, this is how I open my parts too, is just to right click a view and open my part. Well, we got through two today. And then that one just needs dimensioned out and the everything else filled out.